Hello, everybody. Good afternoon. My name is Zia Lennard from R2M Solution. I will be chairing this paper session entitled End User Behaviors and Performance Models. We have 5 high-quality presentations, and we will have Q&A, questions and answers, after each individual presentation. Please don't hesitate to write your questions into the chat window as attendees, and we can unmute you as well during your questions. So please feel free. We've got plenty of time today. We're not rushed. So I'm excited to start. Before we start, I'll just quickly read the contents, the presentation. So first we have Gloria Rodríguez from CEMOSA presenting potential on comfort enhancement and energy saving through behavioral change and of energy users in real European buildings. Next, we have Ricardo Manuel Mafra Barbosa from University of Minho presenting supporting users' decision-making behavior through identification of co-benefits of energy-efficient heating solutions. Third, we have Sheikh Zuhaib, presenting the X-tendo survey, its energy performance certification and schemes. Oh, I'm sorry, that was a typo there. End user perspectives on the next generation energy performance certificates, findings from the X-tendo survey. Fourth, we have Catarina Paisana from University of Lisbon presenting consumer behavioral change model. And then finally, last but not least, we have Sotiris Papadelis from HEBES Intelligence presenting measurement and verification approaches, performance-based models of energy efficiency services. So without further ado, I shall kick it over now to Gloria. And again, please feel free to ask questions. We welcome them. So Gloria, you should now present, and I will shut my camera off.
Okay, so hello everyone. I will present a study regarding the potential on comfort enhancement and energy saving through behavioral change of energy users in real European buildings. The content of my presentation is, first of all, I will introduce the reason for this study. Then I will explain the methodology that we have used, the experiment design, the pilot buildings where the study is based on, and the analysis on comfort enhancement potential and energy saving potential. Then I will present some results, and finally I will explain our conclusions. So the reason for this study is, of course, because buildings consume too much energy, and we need to reduce that consumption. And there is an important potential to reduce that consumption based on the occupant behavior. The objective of the study is to analyze several European buildings, including schools, office buildings, healthcare centers, and residential buildings, to quantify that potential on comfort enhancement and energy saving through the behavioral change of the users. And we also want to identify what are the most promising users' behavior changes in terms of energy savings and comfort enhancement. And finally, I wanted to mention that this study is part of an European project called eTeacher, which started in 2017 and will finish in 2021. And this project has developed some ICT solutions to change the energy behavior of the building of the building users, and this study is part of the first phase of the project before we have given that tool to the users. So this is the context of the study. The methodology, as I said, we have intensively monitored 10 buildings during 8 months from February to September 2019. And the kind of measurements that we have collected is at building level and at room apartment level. We have collected energy consumption data on HVAC, on appliances and lighting, and also the total energy consumption of the buildings. We have collected data related to indoor conditions of the rooms and apartments, temperature, CO2, lighting level, relative humidity. We have also collected outdoor conditions, temperature, solar radiation, and relative humidity, and other parameters such as occupancy or windows open have been also collected. This is the experiment design and the pilot buildings. I want to talk shortly about the pilot buildings. We have 2 schools in Spain. We have one residential building in Spain and 4 residential buildings in Romania. We have 2 healthcare centers in Spain, and we have also 1 office building in Spain. The kind of technology or monitoring technology that we have used in our experiment, this is just to illustrate the kind of technology. We have used several solutions existing in the market. For example, this is the monitoring in one of the apartments in Romania. We have used, in this case, Homematic and MetaMod technology. For example, we have installed one access point here, the letter A in each apartment. Then we have some meter flush mount for measuring the consumption of the appliances and the lighting. Here, this is letter B. Then letter C is also to measure home appliances consumption and cooling consumption. And this is another kind of device. In this apartment, we have installed 3 of these devices. Then we have a kind of outdoor weather station to measure temperature, humidity, and pressure. We have also a sensor to monitor the status of the windows. We have installed 3 of these in this apartment. We have also installed one motion and light sensor in this apartment, which is here in the corner of the living room. And we also have installed one sensor to measure temperature, humidity, CO2, and noise level, which is here in this position. This is one example of the monitoring technology that we have used. Another example is this one. Here we see the monitoring devices that we have used at building level, and here we see the monitoring devices that we have used at room level. At room level, we have used Z-wave technology for temperature, CO2, and relative humidity, for windows opening, for presence and luminance meter, for appliances submetering, lighting submetering, and the temperature of the fan coils. We have also used at building level a weather station based on Z-wave technology, which is wireless technology in this building. And then we have used some wire technology that use RS485 to measure the general electric energy meter, the HVAC energy meter, and the lighting energy meter. And this is just to illustrate the kind of technology that we have used. I just wanted to mention that we have used commercial solution in all the buildings. In general, we have used more wireless technologies than wire technology. Yeah, this is to provide an idea of the kind of monitoring devices. I want to talk now about the comfort analysis that we have carried out to quantify the enhancement potential. We have focused on four variables: indoor temperature, indoor relative humidity, indoor luminance, and indoor CO2 levels. And we have set some threshold based on the standards. So for the temperature, the comfort threshold is in between 21 and 26 grades. Then for relative humidity is between 40 and 60%. For indoor luminance, we have set a threshold of over 500 luxes for all the buildings except for the residential building, where the limit is lower, is over 150 luxes. And then for the CO2 level, we have our threshold is below 800 ppm. And how we calculate the potential to enhance comfort, we have calculated the number of hours where the rooms are occupied, and these variables are out of the thresholds where comfort is guaranteed. Okay, this is the analysis for the comfort, and then the analysis to quantify the energy saving potential. We have defined a number of target behaviors. For example, related to the use of the lights, we define two target behaviors: turning off lights when leaving a room or at the end of the day, or target behavior 2, which is reduce the use of unneeded lights, checking lighting levels and needs during the day. Then related to the appliances, we have defined two target behaviors as well: turn off appliances at the end of the day, and appliances off when away from room for 1 hour or more. Related to the HVAC use, we have defined 5 target behaviors: reducing the thermostat temperature for heating when overheating, increasing thermostat temperature for cooling when undercooling, and ensuring that if heating cooling is on, windows and doors are closed, turn off HVAC system if the room is not used for more than 1 hour, and ensuring the air conditioning and heating are not working at the same time. Okay. So the way how we have estimated the energy saving potential is based on the monitoring data. So we have counted the number of hours that these target behaviors are not carried out by the users of the buildings. Then we have calculated the energy wasting during those hours, and finally the cost of the energy wasted during those hours. So, for example, for target behavior 1, which was turning off lights while leaving a room or at the end of the day, we count the number of hours in every monitoring room that there is no one and the lights are on. In this case, we use two monitoring variables, which is the presence. So when the presence is 0 and the lighting consumption is over 0, then we count that hour like this target behavior is not carried out. Then we calculate the energy consumed, the lighting energy consumed during those hours, and finally we calculate the cost of that energy, just multiplying by the price of the energy at that time. So this is an example. And then I will present some results related to the comfort analysis and the potential to enhance it, and the energy saving potential. So I'm not going to explain the results of all the buildings, and I just focus on 4 buildings. But then in the conclusions, I will provide an overview of all the buildings, okay? Because otherwise it's too repetitive. Okay, so in the case of the office building in Spain, we have in this graph, we have monitored 2 of the 2 floors, which are big offices. So this is the data related to floor 1, this is the data related to floor 2, and then this is the data related to both floors, and these are the percentage of occupied hours where comfort is there is no comfort because of the temperature, there is no comfort because of the relative humidity, there is no comfort due to CO2 levels, and there is no comfort to look to the lighting level. So just to, because it's too small, this is 100% of the occupied hours, this is 20% of the occupied hours, and what we can see here is the main problem related to comfort is the lighting level. So about 70% of the occupied hours are out of the lighting level range. And regarding relative humidity, also about 60% of the occupied hours are out of the range. So if we go to the next building, which is one of the healthcare centers in Spain, and here we have 4 monitoring rooms, and here we have the results of all the rooms. Again, here we have the number of occupied hours that there is no comfort because one of the 4 reasons that we are studying. And here, in case you cannot see, this is 70% of the occupied hours, and this is 20% of the occupied hours. And what we can see here is that the main problem is the relative humidity. So almost 60% of the occupied hours are out of the range of the relative humidity comfort. And then there is some problems with CO2, but only in some specific rooms. For example, in this one here in room 3, there are some problems with the CO2, but just not in all the rooms. This problem is not in all the rooms. If we go to the next building, which is the residential building in Romania, we see here all the apartments. Here we have the results of 5 of the 10 apartments that we have monitored, and here we have the results of another 5 apartments. This is the 40% of the occupied hours, and this is the 20%. And the main problem here is the temperature. So we see that 40% of the occupied hours are out of the range of the comfort range. And finally, regarding comfort analysis, I will explain the results in one of the schools in Spain. And here again, we have data from one classroom, from another classroom, and here from all the classrooms. And this is the 100% of occupied hours, and this is the 20%. And we see here that the main problem is related to the lighting level. Almost 100 of the occupied hours are out of the range. Also, we have some problems with the relative humidity, with more than 50% of the occupied hours out of the range. And also CO2 could be improved. 30% of the occupied hours are out of the range. So these are the results relating the comfort that I wanted to show. This building in Spain, we have the 2 floors monitored. We have here we have both floors, and each of these bars are related to one of the target behavior that I was explaining before. Here we see the energy consumption during the hours where these target behaviors are not carried out by the users. So, for example, we can see, well, this is 12,000 kilowatts hour, in case you cannot see properly the numbers. And here we can see that, for example, target behavior 2, which is reducing the use of unneeded lights, is carried out during more than 4,000 hours from March till September, and this means a consumption of more than 12,000 kilowatts hours, and in euros are 1,060 more than 1,600 euros that we could have saved with a proper behavior. Regarding target behavior 1, which is turning off lights while leaving a room or at the end of the day, we see that this target behavior was not carried out during more than 4,000 hours from March till September, which means we could have saved more than 3,500 kilowatts hour and more than 400 euros during these hours. And the conclusion related to this building are that the target behaviors with higher energy saving potentials are those ones related to the use of lighting. Regarding one of the healthcare centers in Spain, here again we have all the monitoring rooms and the energy consumption during the hours that these target behaviors are not carried out. This is 4,000 kilowatts hour, and what we can see here is that target behavior 8, which is turn off HVAC if no one during more than 1 hour, was not carried out during more than 8,000 hours from April to September. In this case, we could have saved 4,000 kilowatts hour and 500 euros. And for target behavior 6, which is to increase thermostat if undercooling, it happens during, so it didn't happen during more than 7,000 hours from April to September. So we could have saved more than 4,000 kilowatts and almost 500 euros during this hour. So this means that the higher energy saving potential are related to the use of the HVAC system in this case. Regarding the 4 residential buildings in Romania, this is the 1,000 kilowatts hour, and we can see that the main problem is related with closing the windows if HVAC is on. So this happens during more than 900 hours, and they could have saved 900 kilowatts hour and more than 100 euros. And the target behaviors with higher potential are those ones related to the use of the cooling system and the close of the windows while this is working. Okay, and finally, regarding one of the schools in Spain, we have identified, well, this is 175 kilowatts hour. So we have identified that the target behavior 6, which is increasing thermostat if undercooling, happens during more than 1,000 hours from April to September, consuming more than almost 200 kilowatts hour, and they could have saved 21 euros, which is not that much in this case. And the target behaviors with higher potential are those ones related to turning off lights, close windows, and increase thermostat. So the conclusions show that regarding comfort, here is the percentage of occupied hours that comfort is not achieved because of one of these reasons: temperature, relative humidity, CO2, or luminance in each of the buildings. And we can see that all the studied buildings have something to improve in terms of comfort. That in the case of these buildings, it seems the higher potential is related to the luminance. And we were also surprised because we have seen the CO2 levels are quite good in this case. So this is good and important. Regarding the target behaviors, the red color are those target behavior more promising in terms of energy saving potential. So we clearly see that the most promising are those ones related because they happen more and because they have more saving potential. Are those ones related with the cooling system, and specifically to increase the thermostat if under cooling, close windows if HVAC is on, and 10 of HVAC if no one. And the next step is to check other weather conditions. We are also including now an office and a school in UK. And also to deploy these ICT solutions developed by the eTeacher project to see if we can really take advantage of this energy saving potential, which just this is the teacher demonstration that has started this month, in the beginning of this month, so we will see what happens. And finally, to validate this analysis with the results of the teacher demonstration to see if this analysis is right. And that's it. Thank you very much. If you have any question, I'm happy to answer.
Thank you, Gloria. There are a few questions. First, the question is from Ricardo. I'll let him ask directly.
Okay.
Okay, so now with microphone. Thank you for the presentation. It's really interesting work. I was just wondering if why did you use fixed thresholds for thermal comforts? Did you consider using, for instance, an adaptive approach to thermal comfort, or did you find that it would be easier for the variety of functions that you're analyzing in terms of buildings? Thanks.
Let's say we use these fixed thresholds, and mainly we use the standards to choose them. So so it's not. I don't know, when you say adapted, you mean adapted to every pilot, to every person, or I don't know what you mean by it.
No, I understand. I understand that you use the regulation thresholds for temperature.
Yes.
But there are two ways for analyzing thermal comfort. One is to use the static approach, that is from the fixed thresholds for it's very analytical approach, and does not consider adaptation of building users, for instance, opening the windows and the difference between the difference in thermal comfort that you feel between the temperature outside and inside. So that's an adaptive approach.
So it's not an adapted approach. It's
so you just consider a fixed one. Yeah, thanks.
Yeah, exactly.
Okay, thank you, Ricardo. The next question is from an attendee named Monica Wolosin. Excuse me if I've mispronounced your name. And you are unmuted, Monica. Please feel free to ask directly. Okay, I'll ask for her. Did you have any issues about data protection, especially in the apartment?
No, because well, this is of course they have to fill a template of consent form, so we engage them in the project, and they have to sign a consent form, and then we have a data management plan where we say we have a procedure in case we want to use the data out of the project, and so this is how we have dealt with this.
Okay, thanks. And there's another question from Monica. I see you're unmuted, Monica. Do you want to try again? No. Okay. She's asking, can you tell us more about the humidity problems, low or high, etc.?
Well, what we can measure is that for some reason they are not within the range. I think we will probably need to see more where is the problem. If it is probably it's surprised because the CO2 level are okay, so there should be some ventilation. So no, we probably need to see what is the cause of that. So yeah, we just know they are not within the threshold.
Okay, Monica, last chance if you want to try. I still can't hear you, but you're unmuted. Okay. All right. Thanks, Monica. So the next question is from Fausto. Fausto, I'm going to unmute you. Fausto Sands is from Comet. Go
Hello.
ahead. Hi.
Hello.
Hi, sorry, Gloria. I just wondering whether with this the potential changes you can do to those users in case of to improve their own comfort. So I was wondering what kind of whether you will target specific behaviors. For example, you were mentioning that luminance was one of the main problems. So whether you will target specifically that problem and how will you communicate with them and try to convince them on how to change that behavior, and what tools can you use to do that?
So we have within the project we have developed an e-teacher app that provide information. First of all, provide recommendation to save energy. For example, it says in case the lighting are on and there is enough light, natural light, it says specifically you have the lights on while the lights are while you have enough daylight. So please turn off the lights and open the blinds, or this kind of recommendations. So this is one of the things that the app does. On the other hand, it collects comfort opinion from the user. So for example, one user can say it's too cold or it's here, so the facility manager can see and can fix that problem if that person checks that is right. So because they also have access to the monitoring data that we have, then they have some kind of scores related to comfort and relating to energy performance that the facility manager, or in the case of the apartments, the tenants can check and can see, okay, this score is not good, let's see what we can change to improve. And then yeah, they have access to monitoring data, more or less process to make them easier, so they can react. And sometimes we provide some specific recommendations. Sometimes we have, for example, something that they like a lot is a kind of virtual building or digital twin, which is a 3D model of the building where you can see the comfort conditions, for example, all these parameters, temperature, lighting level, also. And when the lighting level is not enough, then the room is highlighted in red, so they can easily see they have problems and they can improve. These are some. There are many functionalities within the app, but these are some of the functionalities.
Okay, so it can even be connected to a BIM program. Okay, good. Thank you.
We cannot hear you. Zia.
Right, thanks. I have a question before we move on to Ricardo. For the residential demos, what is the relationship between them and the project? Are they partners? Is it a building owner that you?
No, they are not partners. They are, so during the proposal phase, they signed a letter that they were willing to participate in our project. So normally one of the partners have a good relationship with that buildings because they have been working before, because they have installed something to them. So normally one of the partners have a good relationship. During the proposal phase, they sign a letter saying, a letter of support that we call, saying we are willing to participate in this study. And so and that's it. And then we have involved them a lot. We actually have a kind of engagement plan where we have done workshops with them, feedback forums with them. We are sending them emails to encourage to use our app. So I must say, at the end, they are happy that we installed these monitoring devices because they are also interested to see their consumption and their comfort conditions. So yeah, that's the relationship.
And this question is for you, but I will also ask all the other presenters unless they speak about it first. How has the COVID-19 pandemic affected either their engagement or their willingness to participate or even your project plan with respect to the end users?
So first of all, these monitoring devices need quite a lot of but need some kind of continuous supervision because sometimes they lose connection, sometimes they are run out of battery. So it's almost weekly we have to check the status of the monitoring devices, and if it is necessary, we need to go there and do some kind of maintenance. So during the lockdown, we couldn't access the buildings. And that means that actually we have to stop the project for 3 months, and now we are back again. So this was one of the problems, that we couldn't access the buildings for the monitoring devices. Another problem was that we wanted to do some training workshops with the users and our app to encourage them to use them, to explain our tools. And finally, some of them we could do it face-to-face, but some of them we couldn't do it face-to-face. So we have to do, we have changed the strategy based on emails and online meetings. Yeah, and that's, and also another issue is that actually the use of the buildings has changed because, for example, now the schools have much more ventilation. Then some office buildings are less occupied, and some residential buildings are more occupied. So.
Great. Thank you very much, Gloria. Very interesting. And now we'll move on to Ricardo. Ricardo, I'll make you presenter. Good. And
Can
just
you see
your
my
web.
screen?
Yep,
yeah.
You're all set. Take it away. Thanks, Ricardo.
So, good afternoon, everyone. My presentation is entitled "Supporting User Decision-Making Behavior through Identification of Co-Benefits of Energy-Efficient Heating Solutions." The idea is that I'll give you an overview not only on the projects we are developing, and Catarina will talk more about it because they had a big part of the study that we did, but also regarding the work in particular that we did in the University of Minho, developed in the scope of the project regarding co-benefits. So please forgive me if some explanations are very broad and simplified, but I will try to focus on more detail in any question that you might have after the presentation. So what is wrong with heating? Well, of course, nothing is wrong with heating. In fact, we need to provide heating to our homes in order to have healthy and comfortable indoor environments. The problem is that we spend a lot of energy doing that, and even worse is that the energy we spend comes mainly from fossil fuel generation. So around 80% of it is generated from fossil fuels. A sharp decrease in energy consumption and use of fossil fuels is needed for the European Union to fulfill its climate and the decarbonization agendas. By one hand, the eco design energy labeling regulations for boilers that is in place since 2015 removed the worst performing products from the market already. But the installed boilers can last for over 15 years, and their replacement rate is really low, like around 40% of the year. So as a result, there is still a large number of inefficient boilers in use today. And normally, consumers are not aware of the costs associated with this inefficiency, but they are quite significant. And we believe this information is crucial to trigger a replacement of the least efficient heating appliances. So in order to investigate this problem, the HARP project was designed with the main aim of raising consumer awareness about the inefficiency of their systems, of their heating systems in particular. The project basically helps consumers to understand the level of energy efficiency of the installed appliance and what they can obtain if they decided to change for a better or a more sustainable and efficient version. There are two principal objectives of the project. One is to increase the replacement rate of old appliances and therefore to reduce associated energy consumptions in the 5 countries where HARP is being developed. And the second objective is to draw lessons from the implementation of a labeling scheme that is produced within the project, of course. So HARP will mainly build on the experience of the mandatory labeling that is already in place in Germany. And the purpose is that recommendations will be used for the implementation of the labeling methodologies for installed heating systems at the European level, but of course more specifically in countries not participating in the HARP. So the HARP project is being developed by 18 partners from 5 countries. There is Portugal, France, Italy, Germany, and Spain. There is a lot of partners, as you can see, but it's coordinated by ADEN, which is the Portuguese National Energy Agency. It runs from 2019 to 2022. And as a main output, he has we set to develop an application that will provide consumers with an indicative assessment of the performance and cost of their heating system. And we'll also be able to compare alternatives in the market. Sorry. So there is, of course, work being developed in terms of the typified quantification of the existing heating appliances in these 5 countries, for instance. But in this project, we wanted to take a little further also and try to tackle issues that are normally not addressed in this kind of studies. So the most common argument for the promotion of energy efficiency investments, such as the replacement of heating systems, it's mainly related with the potential energy and economic savings that are achieved. This is the main argument. But you can consider that there is a wide range of other known effects at various scales that are directly related with this kind of investments. These effects are often termed by co-benefits or ancillary benefits or non-economic benefits or non-energy benefits, if you want, but they can be determined in order to promote the change needed to address climate change with success. So in the context of this study, co-benefits are defined as accompanying potential benefits to the consumer arising from the specific technical and physical characteristics of the heating production system. And they are basically two perspectives you can find in the literature and on the research. There is the macroeconomic scale, where you would analyze benefits to society, normally trying to monetize it, of course, in terms of effects on the fight of climate change, air quality, and on urban areas, for instance, or impact on health, on productivity, etc. And there is the more private perspective. If you want, at a household scale, for instance, that is from making the decision to adopt energy efficient technologies that it's known to be strongly connected with these additional benefits that can range from thermal comfort, easier use, added value of the property, things like that. So we wanted to address that, and we realized that although it's important, it's really recognized in the literature and on the research, there is not it's not a very well explored area, this kind of issues at this scale, at least. So I think macroeconomic scale it's more developed, but at the private perspective it's not so much. So in order to have a clear picture of what's important in each national context of the HARP, we set out the methodology for our study. So this included a first literature review in order to identify the co-benefits that should be included in the analysis. Then we tried to clarify our objectives. So we wanted to understand what is the relevance of each co-benefits for the users or for the consumers, if you want, and how these co-benefits can be valued, because normally the value of investments are just analyzed in terms of economic and energy savings, in terms of economic in general. And we think that the value of investments analyzed like that are undervalued because they're not considered such an important factor in decision making. So we designed together with the partners in the project an international survey that I will discuss a little more in the next slides, but I think Catarina can clarify that with more detail. And we expected to have at the end a degree of co-benefit relevance and some information regarding the willingness to pay for co-benefits for heating devices, or the co-benefits for heating devices. So in the first phase, we did the literature review, and in order to identify the most relevant co-benefits at this scale, we first list I think 27 co-benefits that can be used, and then we used expert judgment from the consortium to try to narrow it down, and got to eight co-benefits that would be analyzed in the scope of the project. So in the table, you can find the co-benefits that we considered, as long as a description that was used to clarify the meaning of the co-benefits. So for instance, in thermal comfort, we would consider co-benefit if we could achieve a higher thermal comfort due to the more adequate room temperature, or for instance, in terms of ease of use, if you consider that ease of use and control of the heating solution by the users will be facilitated, or if the in the added value of the market, if the property would be the value of the market will be improved after the implementation of the heating solution. So the survey was designed in the scope of the project, and we served several purposes. Namely, the main one was the development of the model that Catarina is going to explain, but we integrated some questions that could be useful for us, and then that could serve our purposes as well. So we asked respondents to fill a 7-point numerical scale rating in terms of in order to try to understand a little more the degree of relevance regarding co-benefits. And we introduced also an economic valuation technique called contingent valuation methods in order to investigate consumers' willingness to pay. As you know, willingness to pay is used to measure the total economic and direct value of known market goods, especially when there is a hypothetical scenario, like for instance, in this case, we ask, were you willing to invest an additional value for an energy efficient heating solution if it allows to obtain co-benefits, for instance? So the objective was to obtain a representative sample of the population in the countries where the survey was disseminated. Again, France, Germany, Italy, and Spain. We then use a random sampling methodology that allow us to have a representation by country based on the assumption that we didn't know the exact number of consumers owning an efficient heating equipment. And we got a resulting representative survey sample of about 6,044 complete response. We have 73% of male respondents and 26 female respondents, and the majority of the respondents have a bachelor's degree, around 42%, and 29 a master's degree, so the quite high education. So the results were analyzed using a weighted average value for age, gender, and country. So every completed answers were considered. So in terms of results, our analysis so far allow us to produce a first view on the problem. In terms of degree of relevance, we can observe that there is differences regarding the relevance given to a determined co-benefit depending on the national context. For instance, Italy has the lowest value regarding the relevance of ease of use, for instance, but one of the highest in terms of thermal comfort. Well, as expected, thermal comfort is really relevant in all contexts. By the other hand, results regarding Germany, for instance, suggest a low degree of relevance regarding aesthetics, but the independence of energy price as a co-benefit is highly relevant. We also realized that from the respondents' answers, men in average attribute less degree of relevance to the identified co-benefits than women. We analyzed all the results per gender, per income, and per age. I think yes, and I think I'm bringing gender and income. This was the most interesting. For instance, in Portugal, you can see that this difference is quite visible. as also in Germany, but there is not for every co-benefit. So you have some differences regarding, for instance, in France, you have some men are considering ease of use as more relevant than women, for instance. So as I said, another perspective that you can have to highlight the problem is when you look at the relevance by income levels in each country, there are significant differences, again, regarding levels of income in some of the national contexts. For instance, in France, respondents with a lower level of income that we established as a threshold of 2,000 euros a month maximum attribute lower degree of relevance to the majority of co-benefits, except, for instance, ease of use. Another interesting question is that the attribution of higher relevance to the added value in the market from respondents with a higher level of income in Germany, for instance. So regarding the willingness to pay for co-benefits, we present here for all countries. It's not divided. Well, the results suggest that there is a significant share of respondents that, first, you can see that there is at least 15% of the respondents that are not willing to invest in any co-benefit. This is quite relevant, and we can see some of the relationship that we are going to analyze in the next slide here. But there is a significant share of respondents, 34% in average, that is willing to pay only an additional 100 euros for the co-benefits when purchasing a heating appliance. In particular, co-benefits such as air quality, ease of use, independence from energy prices, thermal comfort, and reduction of environmental impact were the most valued in this space of the we call it tier of the 100 euros. In the space between 100 and 500 euros, the most valued co-benefit was independence from energy price. Around 30% of the respondents answered that, and that was closely followed by thermal comfort and air quality. Of course, as we expected, there are less respondents willing to pay more than 500 euros for co-benefits. But the reduction of environmental impact and independence from energy prices were indicated as the most valued co-benefits in this space. In opposition, aesthetics and useful area were the less valued. So we here, and I'm going to try to be faster. Here you can see that there is a clear relationship between what people indicate as relevant and what the value that they are willing to pay for that co-benefit. And the size of the circles here are indicative of the amount of the response that corresponded to the relation of these two factors, the willingness to pay and the degree of relevance. You have here the spaces of the intervals of the willingness to pay, and here you have the degree of relevance. And in general, results from the survey indicate that although there is this relationship, this is not true for every co-benefit. So, for instance, in terms of added value in the market, for instance, there is 400 respondents indicated a degree of relevance of 7. It's quite high, but there is no willingness to invest in additional value for this co-benefit. I think I believe this is very distinctive from national context to national context. This is just an overall view. But in opposition, for instance, there is a significant relationship between the degree of relevance and the willingness to pay concerning, for instance, reduction of environmental impact and thermal comfort, for instance. So just some general results from that we can extract from each national context from our results. I will skip this because I think I have over the time already, and I think these are more important than more general. So we realize that in fact some co-benefits are more relevant than others, and we can distinguish national contexts as well as other factors that we know that it's important for decision making. But what is also important is that we realize that the most relevant co-benefits in general were thermal comfort, air quality, and also the reduced environmental impact, which is quite interesting. So as I said, we also realize that for different countries, we have different co-benefits that are relevant, and also that we can attribute a value to the co-benefits, and consumers are willing to invest in co-benefits. So as the next step, we want to make a deeper analysis of the collected data, for instance, using cluster analysis, and we want to reflect and understand how we can integrate this kind of information in policy and communication campaigns. So you can know more about the project on our website, and looking forward for your questions. Thank you. We can hear you, Zia.
You are mute, Zia.
Yes, now you can.
Sorry. Yeah, thanks, Ricardo. There's no questions from the audience. I'm going to save my questions until the end because even though we can go long, some people might have to leave. So yeah. Thank you, Ricardo. We'll move on now to Zuhaib, and I will make you the presenter. Good. All right, thanks. Take it away.
Hi, can you see my screen? I hope.
Yes. Just put it in presentation mode, please. Perfect.
Yes. Thanks, Zia. So I would like to present our project X-tendo. I'm from Building Performance Institute Europe, and we are one of the partners in this Horizon 2020 project, which we started last year. It is very important to see how energy performance certificates are developing in the near future. And we are working in this project to see what the next generation EPC certificates would look like. And there are a lot of interesting things that we can see in this project, and I would present them in a very short way because it's a lot to grasp. But the main thing that I'm going to present today are the findings from the survey that we did with the end users in certain countries. So my presentation would include the introduction to X-tendo project, the survey methodology and structure that we adopted in the project, what were the respondents' profile, what were the people who were involved in this survey, some insights on the results, and in the end I will present the conclusions, and then we can head to the Q&A, provided the time is. So moving on to the X-tendo project, the consortium has 13 partners from 10 countries. As you can see on the map, we have partners from Austria, Denmark, Estonia, Greece, Italy, Poland, Portugal, Romania, and Scotland. It's a quite big consortium and very relevant in the sense of EPCs that the countries who are forerunners as well as who are the followers, giving example of the UK and Portugal These are the countries who are really doing well in their EPC schemes and making a real difference. But we also have countries which are lagging behind in implementation of their EPC policies or EPC schemes very effectively, such as Poland, or we can talk about Greece or maybe Romania. So it is a good mix of countries which are working together to improve the existing EPC schemes, how their quality and reliability can be improved, how their performance can be better, in order to indicate the renovation that is happening in different countries, and also promotion of renovation in the coming future. The main objective of this project is to support the public authorities to implement and manage their EPC for the next generation. And as we know that EPCs have been questioned a lot of time in research, as well as in different countries, for their ineffectiveness, their inabilities. So I think this project is going to fill those gaps and try to come up with a strong structure for the public authorities to implement certain new aspects in EPCs and strengthen them. The second objective is to demonstrate and encourage the rollout of next generation EPC, what it will include and how it can function with the existing EPC schemes. It is a big question that how existing EPC schemes can be changed to something bigger and something more important, and how that transition can happen. So in X-tendo, we are going to show that. It is also about improving the reliability, usability, and convergence of practices and tools related to next generation EPCs. So we are working on several methods, several dimensions in which the existing EPCs can be improved. Last but not the least, it's an important part of this project. So by the end of the project, there will be a toolbox of innovative features, and I will explain about them in the next slides. So these innovative features are going to support the implementation for next generation EPCs in different public authorities of different member states. So it will be a toolbox that will be fully adaptable and usable by the 28 member states we have in European Union. It will also be very flexible to what different member states would like to adopt for their EPCs and how would they like to move forward. So moving on to what are these innovative features and how they're going to really improve the EPCs. So in X-tendo, we are proposing 10 new features for the new next generation EPCs, and there are two categories. On the left in the diagram, there's a category of innovative indicators, innovative data handling indicators in green, and on the right is orange, which has innovative EPC indicators. So these 10 indicators include smart readiness, comfort, outdoor air pollution, real energy consumption, district energy, EPC databases, building logbook, tailored recommendations, financing options, and one-stop shops. Now this is a lot that we are working in X-tendo, and that is why there are so many members and countries involved in developing these aspects for EPCs, and how they can be integrated or existing EPCs can be improved to provide information on these different features. Now, one thing that is important while developing these features are the 4 cross-cutting criteria that you can see in the circumference. One is economic feasibility, compliance with international standards, quality and reliability, and user-friendliness. So all these 4 cross-cutting criteria are being taken into account while developing the methodologies for the assessment of different indicators. So these different features that are being developed, they will have their individual methodologies. Different experts are working on them, and finally they will be available as a toolbox at the end of the project. So moving on to the survey, which we conducted within the X-tendo. So this survey was conducted to find about the knowledge of end users on different features, and to understand what understanding they already have about these features, and how can we really make it simple and understandable for the next generation EPCs. So this survey was basically conducted to know the understanding of end users, who are the owners or the occupiers of different buildings, and that is why the target group for the residential end users for EPCs. It was an online survey, which was approximately 20 minutes. So the sample size was approximately 500 participants from 5 countries, and these countries involved Denmark, Poland, Greece, Portugal, and Romania. Denmark and Portugal are the forerunners, as I mentioned to you before, and then there are followers such as Poland, Greece, and Romania. So there was a reason behind selecting these countries, and of course, within the budget of our project, the survey structure that was adopted for X-tendo was based on different aspects that we could inquire with the participants. So it involved the demographic related questions such as age, location, family composition, and income levels, their location, urban or rural, tenure status of the respondents, such as are they owner-occupied buildings or they're rented buildings they're living in, the type of buildings they are living in, detached, semi-detached, apartment buildings, and of course the countries. So the survey structure took into account these dimensions very closely. A total of 2,563 end users took part in the survey that covered homeowner, landlords, and tenants. The age bar was 18 years and above who participated. Three aspects that were important in the survey was only participants who have bought, rented, sold, let, or renovated a property in the last 5 years were permitted to participate, along with ones who attempted and also who has taken some first steps to buy, rent, sold, or renovated the property. So this was basically the survey structure and methodology that I explained. Now I would like to move on to the respondents' profile. The vast majority of respondents were homeowners themselves, about 69%. Almost 1/3 owned at least one rental property. Among the respondents that bought the property started to do so were majority 58%, and only 8% plan to rent it out. Half of the respondents planned or thought about renovating in near future, and about 29% were not thinking about renovation. 2/3 strongly agreed that renovation could reduce their household energy use. This was one of the questions that we asked them in the survey, that how important it is for them to reduce the energy use. So I will now jump on to the 10 features individually. There were many questions asked for individual features, so I would ask you to visit our website. In the end, I will share the link where you can find the report, which is a very detailed report. Here I will be presenting only very key results for you to understand the feature and the kind of question that was asked to them in that feature. First, I will talk about smart readiness. Many of you might be aware of this smart readiness indicator, which is an ongoing project with the European Commission. The smart readiness indicator is being developed. Similarly, smart readiness is a concept derived from smart readiness indicator. It is more or less similar in the methodology, but the experts who are developing a smart readiness indicator are also working with us in developing a smart readiness indicator for the EPCs, and how it could be integrated, how a methodology can be integrated with the EPCs so that the assessment of a smart readiness can be done along with the EPCs if a member state wants to do so. So they were asked that how familiar are they with the smart technology, and you would see that quite a good percentage of people who agreed or strongly agree with their familiarity with smart technology showed that people are interested to increase the comfort of their homes through smart devices or smart equipments. They also agreed that smart homes help them to save energy. There were issues people that raised about the security of their data. We could say they lack overall knowledge about smart technologies. They're not very well familiar, but they feel that it is interesting for them to conserve energy and increase the comfort. And they also said that it would be interesting to include some information in the EPCs about the smart readiness of a building. So I shared here a few insights. Of course, there are more graphical representation, but they would be in the report that is available on our website. So feel free to visit that and see in detail. Next feature that I will talk about is comfort. Very relevant. In the previous presentation, we saw how comfort is being regarded as one of the most important aspects in today's time, along with energy efficiency. So this feature is basically being developed in X-tendo. It is going to be a methodology which the assessors can use on site and also indicate the level of comfort in the EPCs of a specific building. So we asked the respondents about would they be interested in information on comfort. So it was level of indoor air quality as an example that we asked. And there was a strong interest from the people who completed renovation, or they are currently doing the renovation or haven't renovated. So basically, there was a strong interest, and users gave priority to comfort when buying or renting a property. There was great interest in comfort levels of the property. Indoor air quality and thermal comfort was seen as the most important elements of comfort at home by the respondents. And adding information in EPCs was definitely regarded as an important aspect by the end users. So moving on to the third feature that we are developing in X-tendo is outdoor air pollution. This feature basically outlines the impact of buildings on outdoor air pollution, and also the impact of outdoor air pollution to the indoor air quality. So it is an interesting feature, but might not be relevant for all the countries where the air quality is really good. But for countries like Poland and Romania, they showed a great interest in this kind of feature, where outdoor air pollution is a problem in cities and in the whole country as in general. And people would like to get this kind of information in their EPCs, that is their dwelling contributing more to the outdoor air pollution or not, and or the outdoor air pollution is having higher impact in the indoor air quality of their buildings. So you could see that there is definitely an interest from Greece, Romania, and Poland, and that is something interesting to see here. Moving on to feature number 4, that's real energy consumption. We know that operational energy versus the simulated energy that we know, or you say calculated energy, is a question that is being raised consistently within EPCs, and it is one of the most important aspects in EPCs, that we should know what exactly is being consumed, not calculated. So real energy consumption feature is going to outline the real-time feedback on energy use, and we asked a similar question to the end users. So on the graph, you can see that there was a high interest, that they said, if I would be able to see a real-time feedback of my energy use via a smart meter, it will be very helpful in understanding or managing the energy use at home. Majority of respondents find this information important for the inclusion in EPCs. Now that there was a difference, as we could say in Denmark, or say countries which are forerunners, this information is already provided. That's why you would see that there is less interest in such a feature of including EPCs. So our intention of including different countries which are forerunners and followers, to also to understand that there's a different appetite, a different level of requirement of these features in different countries, and that would help us to develop them accordingly. Moving on to the 5th feature, that's district energy feature. It's also very interesting. Among the 5 countries, Portugal was not surveyed for this particular feature because there's no district heating. Other than that, we surveyed the rest of the 4 countries, and district heating was more interesting for homeowners than tenants, especially in the denser areas such as cities. There was interest by full-time employees and full-time parents were significantly interested in district heating information, such as that how far the district heating grid is from my home, what is the efficiency of the district heating grid, things like those. So we asked a lot of questions, and the more information is available in the report. This was also one of the interesting feature to survey with the end user of different countries. Moving on to feature number 6, EPC databases. I would like to explain that EPC databases is not directly related to the end users, but it is basically limited to the authorities or public authorities who are managing EPC databases. But questions like asking the end users, are they interested in information of energy performance scores of similar buildings nearby? Now, this kind of information is available in EPC databases of some countries, where people go and check, okay, in my PIN code, what are the general energy performance score of different buildings? And that gives you an understanding that my building is not efficient or very efficient compared to the other buildings in the region. And it has an impact on a lot of other aspects, even the financial value of your building and things that are like that. So EPC databases is a feature that is being worked upon in X-tendo, where the databases are being refined, they are being developed in a more cohesive way, where such information can be stored and easily available to public there's a high interest in this information from on similar buildings across all groups. Information needs to be presented in an easy accessible format so that anybody can access them in general. So EPC databases. After that, I need to feature 7, which is building logbooks. Many of you must be aware that different projects are going on in the European Union on building logbooks. It is regarded as one of the most important tools to promote renovation and decarbonization by providing building logbooks. Some countries have already started utilizing building logbooks. But for the project, what we are trying to do is to make a connection between EPCs and building logbooks. We know a lot of information is already collected for the EPCs. So if such a feature could be developed, then how building logbooks can be utilized with the EPCs? We asked them a question regarding what kind of information is useful to the owners and renters. And you would see in the graph that they were most interested in information such as condition of walls of roof, or age of the equipment in the building, windows, glazing, and insulation, and renovation activities completed up to date. So there was a large interest shown in this kind of information available to them. So we are working on a feature that could be integrated with the EPCs and could provide or record such an information, and that would be useful for the owners or tenants in the future. Moving on to feature number 8, which is tailored recommendations. We know that it is very important for an owner or a tenant to know what they can really do to improve the conditions inside their building, such as the comfort levels and of course energy efficiency. But they are interested in receiving certain specific information in order to plan for them. So tailored recommendations are basically focused on providing them tailored feedback based on the EPC that they will receive. So for that, we asked them specific questions that what kind of information would they be interested in. And in the graph, on the results on the right, you would see that they were mostly interested in cost-related feedback, such as estimated cost of each renovation measure, expected impact of renovation on energy cost, maintenance and operation costs linked to the renovation. So all the countries showed great interest in this kind of information in tailored recommendations, and that definitely help us to prioritize certain kind of information that we will be working on integrating tailored recommendation with the EPCs and using the strengths that already exist of EPCs to derive certain tailored recommendation based on the interest of end users. Coming to the second last feature, that is financing options. We know that if we are given information on how we can finance our renovation, what kind of bodies we have to approach to get some information, what kind of information I would be looking for if I have to renovate a house or a home. So this feature is developing a key support to the end users, and that would definitely give a push to the renovation in Europe. And if such an information can be provided with the EPCs, so this feature is being developed, and we asked the question among others questions. So they were most interested in information on maintenance and operation costs linked to renovation, and in some countries they were also interested in expected impact for renovation on energy costs. Greece and Romania showed highest interest in maintenance and operation costs, whereas Portugal and Greece showed interest in receiving information on estimated cost of renovation. It was interesting to see that people with 35 plus years of age were most interested in renovation, but have lower financial capacity. So there are a lot of cross results that you would see in the report based on the demographics, the income levels, the ages, and location. So I couldn't present all of those results here, but that is definitely very interesting to look at how people perceive all these features differently. The last feature that I'm going to present here is one-stop shops. Now, we know that one-stop shops are being pursued as one of the major areas in the European Union where people could go and get all the advice for their renovation on finance, on what they want to do, how they want to do it, what cost will incur. So all that information, if we are able to create a mechanism or a methodology through which people are connected with their EPCs, So we know that OSS have a direct link with EPCs, and they are the major source of building energy efficiency information that is available in Europe. We know that they could be linked to building logbooks and financing schemes as well. So I presented previous 3 features could be directly linked with one-stop shops. Approximately 82% of respondents express interest in using the OSS services. And there was a very high interest in consultation of technical solutions for innovation. You can see on the graph on the right that owners and renters, they showed a high interest in consulting for technical solutions. So here I finish on all the 10 features. There is a poll time. We have a few polls for you. And we would like to ask for your feedback on certain questions. So it would be good that you can give your feedback in the polls, and then we can move on to the next part of the conclusions. Can we start the poll, please, Zia?
Yeah, it's already started. All right. I'm going to give it 10 more seconds for everyone else who hasn't voted. All right, here are the results. Zuhaib, do you see those on the screen?
Unfortunately, it's asking me to. No, I'm not able.
I can read them.
I can see the results.
Yeah, so can I. I can read them for you, and they'll be supplied afterwards. So 67% said real energy consumption, 33% comfort, 33% building logbooks, 100% one-stop shops. I don't see how that's possible, and 0% smart readiness indicator. 43% of the attendees voted. All right.
I think, thanks for the results. I think there is a great potential in each of these features that I ask you to give the poll. Of course, real energy consumption is targeted to a wider audience who already have EPCs, and we have been struggling to get this real energy consumption as a part of EPCs from long. Whereas OSS are concerned, they are definitely one-stop shops where everybody wants to get advice for innovation. It's a big exercise that is happening that is also concerned with financing options, building logbooks that we have. And for comfort, I'm a little surprised because the end users, on the other hand, showed a very strong interest in knowing what are the comfort level inside their buildings and receive this information in the EPCs. Can we move on?
Yep, poll number 2. Oh, looks like we've got a 3-way tie here. 33% only a few, 33% yes, and 33% not sure, 0% no.
Could you please repeat the question?
Sure. Should all 10 features be included in the EPC? And 33% only a few, 33% yes, 33% not sure, and 0% no.
Thank you. I mean, it's a great question. Which feature would be really interesting? It's really difficult to decide, but all of them have certainly an interest somewhere in the audience, and I'm happy to see that there's a divided attention to many of them, and definitely shows that some features have more capability and more potential to be included than the others.
Okay. Next, there are 2 more polls. Which target groups are most relevant for new features? The choices are young people less than 30 years old, older people more than 55 years old, families with children, people in urban areas, or people in rural areas. And you can select more than one, I believe. All right. Give it another 15 seconds. Oh, we're getting more engagement. Now we have 50% voted. All right,
That's great.
5 more seconds. Okay, here are the results. Which target groups are most relevant for new features? We have 80% young people, 40% older people, 60% families with children, 100% people in urban areas, and 60% people in rural areas.
Very interesting result. I think the more people are informed about the benefits of these features, they are more likely to opt for many of them, especially we see that real energy consumption interests people, and the young audience is of course more informed than the other audience, and in urban areas potentially people are more educated, and there's a different variety of responses we are getting here, but it is interesting to see the results.
Okay, and the final poll. Would the addition of new features put pressure on the market to make buildings more efficient or healthy or environmentally friendly? Please choose yes, no, or not. An astounding, overwhelming yes. Oh, now we've got a 20% not sure. I'll give it another 15 seconds. This is the highest engaged poll, 71% voted. 10 more seconds. All right. Okay, so would the addition of new features put pressure on the market to make buildings more efficient or healthier, environmentally friendly? 80% yes and 20% not sure, 0% no.
I think I agree with the people who says yes, because we are receiving an overwhelming response from our partners who are also in the market and also the public authorities. They're already working on them, especially in Portugal and countries like Denmark and also Estonia. And we do expect that it's going to put pressure on markets to bring in more people with trained skills and also new measures taken up to introduce these features. Of course, it's a big task, but I think we are positive about it. So thanks, Zia, for launching the polls. I would like to now move to the conclusions of the presentation, and thank you for the participation to the audience in the polls. It was interesting to see all the results. So I would like to conclude here that we saw that younger people are more interested. That is supported with your polls as well. Older people are interested in features like comfort, energy consumption, building logbook, and renovation information in general. Regarding the tenure status, we saw differences between owners and tenants, and the responses were not, the differences were not very large. Tenants do not have always to pay the cost of renovation, but they do find this kind of information useful for their planning, or maybe moving into a house, or maybe buying that property where they're living. So there is definitely indecisive thought there. Regarding location, we didn't saw a lot of difference in urban and rural locations, but people in rural areas were more interested in features like outdoor air pollution, and whereas people in density areas were more interested in features like district heating. Regarding the EPC status, people who have already got an EPC or not, they were more interested, and people with an EPC were more interested in features like smart readiness, comfort, and building logbooks. So here I conclude with the thought that there is a positive future coming, and we are working with an X-tendo with all of these interesting features. You can log on to or you can just reach our website xtendo.eu to see different reports and different work that we are producing within this project. So Zia, if now you can take up and see if there are any questions.
Thank you very much, Zuhaib. Very interesting. I will save my questions for the end. There are none from the audience. So thank you for that. And next up, I will make Catarina the presenter. Catarina is Catarina Paisana Pires Costa da Neves, excuse me if I messed that up, from Nova University of Lisbon, Nova Information Management School, and Catarina will be presenting consumer behavior change model. So have I made you presenter yet? Not yet. Here we go. All right.
Hello. So my name is Catarina, and I will present the consumer behavioral change journey or change model. I'm representing my team of Nova University of Lisbon, Nova Information Management School, with Tiago, me, and Joana. And basically, this behavioral change model was done in the HARP project, within the HARP project, that stands for Heating Appliances Retrofit Planning. It's a Horizon 2020 project, funded project. And basically, the main idea is to motivate individuals to plan the replacement of their old and inefficient heating appliances to new and efficient alternatives. So basically, what we propose to do is to define the consumer behavioral change model, which means that we will try to understand what are the drivers of this consumer adoption for a more efficient heating systems. Okay, so as we know, more than 50% of the equipment perform C or lower. So it is really there is really a need to motivate these consumers to change these inefficient heating appliances. So to achieve our goal, we decided to carry a survey. And then just some simple statistics and descriptive analysis. Then we go to our big method, that is the partial least squares, and then we will take some results. Okay. So first, we started with some literature review and discussion with the consortium. So we needed to start to see which variables could be affecting the intention for a consumer to change and can be a driver for this change by the consumer. So we started to see some studies that already exist on the topic and gathering some variables that could explain this, but also talking with experts, because with experts we can add some other variables that actually were relevant in explaining this behavior. Then we select the variables we include on the survey. Before going to run the survey through, well, the European countries, we first decided to do a pilot survey, then make some changes, and then we run the final survey. So the survey was out for more or less 2 months and a half, and we gathered about 6,044 complete responses in France, Germany, Italy, Portugal, and Spain. So after gathering these responses, we decided, okay, we need to see some descriptive statistics of this sample to understand more or less if this is representative of the population, or at least of the responsibles that usually make the decision of changing the heating appliance. And basically all these statistics are really similar to previous studies on the topic. For example, the number of years of education is a little bit higher than the usual for each country, but which is normal because we run an online survey and this is like a specific topic, so it requires, well, a little bit of more knowledge in this topic. Also, the average energy consumption, we can see that France is where we have the higher energy consumption in euros, in Portugal the lower energy consumption. Okay, so basically we did this survey, gathering some variables, we collect the responses, and at the end we decided, before running like the big methods to understand this, we decided to do what we call a factor analysis. In the factor analysis, basically the ideas behind is that we have like a set of variables, radio, TV, and so on. And instead of using those variables, all those variables in our analysis, we will try to simplify and try to find another variables that will represent basically the same information, but instead of having like 10, we will have just 3. And we did this for communication channels that were one of the variables that we decided that could impact consumer when the consumer intention to change the heating appliance. And for example, we can see that radio, TV, and newspaper are really correlated, and they form the communication channel, the media communication channel. This is just one variable. We did the same here: installers, stores of energy efficient heating appliances, organizations, people that I know that are all gathered in organizational communication channels. And then we have websites and mobile applications that are in the web media communication channels. And nowadays this is actually really interesting, because it's good to divide the web media from the usual media communication channels. And we did this for communication channels, but also for the co-benefits. So these co-benefits basically are benefits that the change of the heating appliance can bring to our health, to the health of the house. So some other benefits beyond just the temperature. So we are talking about comfort, we are talking about the health of the house, also some price issues, and so on. So we have like here a lot of variables, and at the end we could finish with co-benefits, investment, and just co-benefits. So the difference between these two is that the co-benefits investment are related with my willingness to pay to having those co-benefits, and just the co-benefits relate to the importance that I give to the co-benefits, because sometimes I can say that, okay, I think having, for example, a more useful living area is important, but maybe I'm not willing to pay for the co-benefit. So before running like the big method, we decided to to do this factor analysis, and we have media, organization, and web media communication channels as possible variables that can influence the consumer to change the inefficient heating appliance, and also the co-benefits investment and just co-benefits. Okay, and then we run the method that is the partial least squares. Is a structural equation modeling technique. I will not go like too deep on the specifications of this technique, but what happens is that this is like a really robust technique, because I will show here on the model. This is our consumer behavioral change model, where we can see here some variables that can be triggers to the consumer intention to change to efficient heating appliance, others that can be barriers, others that are related with engagement. It's good to understand how engagement, social influence can affect the intention to change. Also some house characteristics, and then we have here the co-benefits and the communication channel. And what happens with this method is that, for example, maybe in a direct relationship, savings can be really important for the consumer to change the heating appliance in a direct relationship. But what happens here is that using this method, I usually say that it is similar to the way people think, because we think on a lot of factors at the same time and not in just direct relationships. So maybe savings are important for this intention to change, but in the overall scenario, so comparing with label, with operation and maintenance, with engagement, social influence, and so on, maybe it's not so important as other variables. And these kind of insights are really interesting. Okay, so basically we build this model with variables that we think, and based on literature and with the consortium, we think that can impact the consumer intention to change to an energy efficient heating appliance. And here we have, well, we need to see if our model was good or not. And here we have like internal consistency and convergent validity, some criteria that we need to check if our model is good or not, or if it will explain what we want them to explain. So we check the composite reliability, average variance extracted, and indicator reliability. Also here, the discriminant validity. Basically, some of these measures is basically to understand if the items that we use on the survey to measure savings, label, operation and maintenance are actually measuring that variable. Because another thing that makes this method really robust is that we will not ask, is savings important for you to change your heating appliance? It's just like one direct question, and most of the times the answer by the consumer has a lot of subjectivity, because it's just one question. Maybe, is label important? Is social influence important? So we decided, no, we will do more questions related with savings or with engagement to actually try to measure the impact of that variable, and not just with one question. So here basically what we want to understand, if those questions that we used to measure savings and so on are actually measuring the savings. And all of this was checked. Also, in the formative constructs, we need to assess multicollinearity with the variance inflection factor, which means that all the items were statistically significant. So we can move on to the structural model. So here we have the results of our final model with the data from all countries together. And what we can see here basically is that all the arrows that has asterisks, it means that are relevant to explain this intention to change to an energy efficient heating appliance. And we can explain here with the R squared 62% of this intention. So this measure is a measure of the explanation power of the model. It means that this behavioral intention to change, consumer intention to change, we can explain this intention by 62% using these variables, which is actually a lot, especially when compared with other studies on the topic. Of course, not exactly the same, but we can see here that we have like a really good power of explanation. And the next step was, okay, let's run this now for each country, because of course for each country some variables will be more relevant than others, also because of the living conditions and so on. For example, in France, we decided, we explained 78% of this intention. Most of the times it means that here we have more agreement on the factors that actually make a consumer to change to energy heating, efficient heating appliance. Okay, sorry. On Germany, we have 74.5%, Italy 43.1%, Portugal 62.7%, really similar to Spain. There is also 62.8% of power of explanation. So here, basically, we have a scheme that summarizes all the results from the previous schemes. So what we have here basically is all the variables that have an impact on the consumer behavioral intention to change the heating appliance. And the first one that appears, it has more impact. The second is the second with more impact, and so on. But overall, all these will have an impact on the consumer intention to change. For example, what we can see is that on France, official campaigns from national authorities and energy agencies are really relevant for the consumer to think on changing the heating appliance. Also, if the appliance has a positive label, then here is actually really relevant receiving information about the heating appliances options, because this is like a topic that maybe not all consumers are aware, or at least aware of the options. So the fact that consumers can receive information, the more information they receive, the more interest they will have, and the more will be the intention and willingness to change to an efficient appliance, especially if this information, as we can see, comes from official campaigns of national authorities and energy agencies. Also, the energy and monetary savings are relevant, and here the willingness to pay for house and consumer well-being. When we go to Germany, we can see that the well-being is the most relevant thing. Like if I achieve this well-being by changing the heating appliance, I will actually change the appliance. So promoting these kind of things is relevant to make a consumer to change the appliance. And basically what we can see here, for example, is that basically in all countries, well-being and official campaigns are really important. And this is actually interesting because we are seeing like a change, because most of the times we think on monetary issues, when people are now more focused on achieving well-being. And well, this is an interesting insight. Also, changing if the appliance will change the low performance, energy performance of the house. Usual Germany consumer will be more intended to change the heating appliance. Also here we have inner social circle opinion, and if it has easy maintenance and operation. When you go to Italy, we can see here again the well-being, so willingness to pay for house and consumer well-being. Also increasing house energy efficiency. Here we have the social influence and again receiving information. So we are seeing here some differences on the importance of the variables, but actually we have here a lot of similar variables from country to country. For example, when you go to Portugal, we have here again well-being, but for example the second one is an easy maintenance and operation. So for a usual Portuguese consumer, if I don't have to do much work, I don't have work with maintenance and operation, I will be more willing to actually change my heating appliance, for example. And it's more or less similar with Spain about receiving information, social opinion, and again here maintenance and easy maintenance in the operation. So although we have some differences because some variables appears on the first place, on the second one, and so on, but we can actually summarize here the main findings. And the main findings are related with co-benefits, influencers, and local organizations and energy agencies. So regarding co-benefits, we can see that in a general way, consumers are more likely to replace equipment in exchange of benefits that it can bring to their in-house's health, comfort, and so on, which means that, as I said before, people are much more willing to invest on their well-being and not just in monetary issues and so on. They value much more the well-being nowadays. Then we have influencers. So social circle and connections are really important in consumers' life, and in consumers for heating equipment, well, it's not different. The consumers will value their friends, relatives' opinions when changing to an efficient heating appliance, which makes sense, especially well, some years ago, and nowadays even more, because people can actually share their opinions so easily. People can communicate so easily, can make reviews. So it makes sense that this kind of factors will have an influence on every consumer's life. And then we have local organizations and energy agencies. This means that, of course, public opinion is relevant, is important, but we are talking about something that is well, with some details, with some specifications. It's not like just a usual shopping. So information from specialized organizations, specialized opinions and advices are really very relevant also here. And then to finish, we decided, okay, we saw what were the most relevant factors in influencing consumer intention to change to efficient heating appliance. But well, let's see within the communication channels, which communication channels are more relevant or not in each country. And especially for the organizations in communication strategies, this is really relevant because with this project, we not also say what people are, which factors can influence more the consumer, but we can also say by which means should we deliver that information. Because if you have the right information, but we don't use the right means, well, maybe that will not have so much value. So what we can see here, like in an overall, we can see like local organizations and energy agencies, people that I know here in France, and local organizations, stores of these kind of equipments on France. Also in Germany, we have people that I know, stores of heating, energy heating appliances, and also here local organizations, installers, and here again people that I know. And then we have also the websites we have here radio and websites and mobile applications, radio and mobile applications. So what we can say, like in overall, we can see here that organizational communication channels are the most relevant ones. So communication through these kind of channels will have much more impact on the consumer when he wants, well, in the willingness for he to change a heating appliance. And also here we have mainly web media communication channels like websites and mobile applications, which, well, it's in harmony with the digital transformation, right? Because now maybe it's not worth to invest on strategies and campaign strategies, communication strategies through TV, radio, or newspaper. Radio, well, it's more or less relevant, but all the others not so much. So we are seeing here that websites, mobile applications, and these web media communication channels are much more relevant, because maybe most of the times people that will be more interesting on this will search this on the internet and just not going to the TV and don't pay so much attention to TV or newspaper. So thank you for your attention, and that's it.
Hello, everybody. My name is Sotiris Papadelis. I represent a company that's called HEBES Intelligence, a Greek company that's participating in a project that's called Sensei. It's an Horizon 2020 project. It's an ongoing project. And a major part of this project is measurement and verification of energy efficiency so that we can create performance-based contracts around energy efficiency services. And this is the topic of this presentation. So very briefly, I will say a few words about the project, how measurement and verification is part of this project, what we have done so far in terms of measurement and verification so far is meaningful here because we have consumed 1 year, still 2 years left for the project. So there are a lot of things that we plan to do in addition for measurement and verification. A very small mention on the Caltrac set of methods, because we actually try to extend them so that we don't build things from scratch. Then some examples of what we do in terms of pre-processing and some things about post-processing of the whole process of developing baseline models, where you can find additional information, and then any comments and questions. So, Sensei is an acronym for Smart Energy Services to improve the energy efficiency of the European building stock. It's a 3-year project. As I said, we have already covered 1, 2 years remaining. The website is presented, and this is the list of the partners. What is the goal of the project? Why we do it? So it says here, it's 2 things are underlined: transactable resource and power grid resource. So it says that the overall goal of the project is to propose services that allow energy efficiency to be treated as a transactable resource. Transactable means that you can build transactions around it. You can measure it and then exchange it, and then pay for it, and etc. We are not saying that it's the first time ever someone thinks about energy efficiency as such a resource. You can think of the ESCO model as one way where energy efficiency becomes an aspect of a transaction. We just want to expand this a bit, and also to expand it in a direction that would allow energy efficiency to be valorized as power grid resource. In terms of why we want to expand the ESCO model, a lot of the work that we do is based on a continuous comparison between things in terms of business models and business models innovations that have happened in the renewable energy domain, and how some of these can be adopted in the energy efficiency domain. And we have already identified a series of obstacles that make these two domains not so easy to adopt models from one to another. One is the aspect of measurability, let's call it. You can measure energy generation, you can have a meter, it's something positive, it's something there. Energy efficiency is estimated. It's always estimated through predictive modeling. So there is increased uncertainty, there is potential for disputes, there is a lot of work to be done in terms of how you measure, how you estimate in a transparent and mutually agreeable way. Then renewable energy, it's energy, there is demand for it, so you can compensate it through energy markets. It's not the same with energy efficiency. Although energy efficiency does have impact on the energy markets, there is no one there to capture these benefits and distribute them back. So it's actually not possible to be valorized through energy markets, but we try to see if it can actually be valorized as something else, as a capacity resource. In the renewable energy domain, you can find existing business models for financing and deployment. One idea is the energy as a service, where someone can install the equipment, is owned by someone else, is operated by someone else. You can lease it, and etc. All this very flexible, very innovative. When you're talking about energy efficiency, usually we're talking about the traditional energy performance contracting model, which works mainly in some specific markets, what they call MUS, municipalities, universities, hospitals, schools. And it's difficult to use it as a building block where you can actually increase the number and the nature of the different actors interacting with it. So to create more complicated models and services. And also there's this aspect of aggregation. There are already ideas and ways to aggregate produced energy. It's not so straightforward to aggregate energy efficiency or energy efficiency projects. There are some ideas that are mainly about ways to implement energy efficiency programs. One can find such an example in Switzerland, the pro kilowatt program, where it's actually an energy efficiency auction, but it supports projects, but also programs. So it can give money to facilitators that actually go and find project opportunities, and in that way, there is a way to aggregate. If you go to the website of the project, you will see a lot of mentions about pay for performance, P4P. As an idea, it's one way to say that you actually compensate something based on the way it performs, not on its costs, no based on deemed results, but what actually is the outcome. And we use the concept of pay for performance in Sensei as a way to bridge all the services and business models. So as a universal interface between all the involved parties. And again, the ESCO model is actually a performance-based model. So we're not trying to reinvent the wheel. We just want to expand it mainly through a direction that allows the design of programs that support energy efficiency by compensating, and this is what pay comes from, in pay for performance, the retrofits, the retrofit projects based on what they deliver, energy savings, for instance, and not expectations and deemed results, etc. Now, in terms of this idea of compensating energy efficiency as a grid resource, we have identified 3 different ways through which we can link energy efficiency to the local power grid and its operational goal and challenges. Saying that energy efficiency has impact on the grid is self-evident. Okay, you can reduce through energy efficiency. You can reduce demand, and this may freeze up resources in terms of distribution lines or capacity assets. But the challenge is to actually link them together in a coherent way. And these 3 ways that we have identified actually differ in terms of the degree of involvement or endorsement that is required from the power grid's main actors, regulatory authorities for energy, power system operators, and utilities. So if you see this diagram, the closer you are to the power grid, the more involvement and endorsement you need. So in this way, you can think of it as plan A, plan B, plan C. So we start with a plan A, which is the direct procurement of demand side resources. And then we say, okay, if we find as a project that there's not so much involvement and endorsement from power market actors, then we can fall back to plan B, which is energy efficiency as a collective asset in energy communities, and then even go further as a plan C, which is just use the concept of pay for performance as a way to design local and regional programs for energy efficiency financing. I have one slide for each one of these three different ways. So what do we mean about direct procurement of demand side resources? The idea actually comes from the existing paradigm in California and what the California system operator, CAISO, does in terms of supporting energy efficiency as a grid resource. And there is this bifurcation decision where they actually split everything into two buckets. And in one bucket, you have demand side resources that can be optimized, dispatched, controlled by the system operator. You can think of it as demand response. And then in the other bucket is what they call load modifiers. Load modifiers are resources or programs that are not seen or optimized or dispatched by the energy or capacity market. But nevertheless, they do have impact on the load shape in a way that actually improves, makes easier the system operator's operation. And in that term, it has value. And one way you can think of it, how this could be done in terms of load shaping, how load is shaped. It's shaped in such a way that there is less need for peak capacity, or there is less need for ramping reserves when you have the duck curve effect in California, where you have to ramp up electricity generation to go from a period with low demand and a lot of renewable generation to a period during the evening hours where you have lower energy generation but higher demand. And load modifiers are compensated through programs that identify and support measures that are most effective in offsetting the need for new generation plants, new capacity in terms of generation, or in new capacity in terms of transmission lines. And it's one way to actually create a link where you provide compensation so that to steer energy efficiency measures, interventions towards measures that are beneficial not only for the building but also for the grid. And then we say, okay, but let's have another option too. And this is an option that focuses on energy communities. There's a lot of discussion about energy communities right now. Usually when we talk about energy communities, we're talking about a collaborative activity, and usually this is related to energy generation, production of electricity. But we're actually in a process in the assessing project to see how energy efficiency can actually be part of the operations of an energy community. Because if you think about it, in an energy market, there's no equivalence between producing energy and conserving energy. Okay, but in an energy community, there is. If the goal of an energy community is to increase its energy self-sufficiency, for instance, actually both producing electricity and then sharing it among its members and producing savings, they're actually equivalent in terms of the same the attainment of the same goal. And the last idea, the last plan is to engage with public institutions with both a budget and a mission to promote energy efficiency and facilitate the design of energy efficiency programs that link compensation with specific performance indicators. So not just give money based on expected costs, but link compensation with specific performance indicators. And the nice thing about it is that the performance part of the pay for performance can actually include a lot of indicators. Some of them could be related to producing energy savings, promoting new technology, but also social aspects like mitigating energy poverty. So not only induce energy savings, but induce savings for households that actually suffer or risk of suffering from energy poverty. Okay, given all this context, where measurement verification comes from, the idea is that anything we propose is sensei in terms of business model. You can think of it as something like that. So there is a definition of performance. You define performance through performance indicators. You link compensation agreements with this performance indicator. So these performance indicators trigger the value allocation between different parties. And you need a measurement and verification process because you need to collect data and estimate what you need to estimate so that to quantify these indicators. What we have done so far in terms of measurement and verification, what is the contributions of Sensei so far? What we have done is that we have said that a lot of work, the state of play right now, is mainly focused on the development of predictive models, the baseline models. And this is fine, and this is also supported by all the standards that focus on evaluating the predictive capability of these models, so to identify if they fit well and can be used, or they don't fit well and they shouldn't be used with a specific building. What we care about in the project is also to understand the dynamics of the building's energy consumption. So not just predict, but have a better understanding. And for this, we have come to the conclusion that it's not so much the model per se, but what you feed your model with and what you do with its results. So we focus more on a pre-processing and a post-processing stage rather than the model per se. For the models, the models that one can find right now are perfectly adequate. There is the Caltrack set of methods for which I have just 2 slides. There are other tools like the MNV tool that has a simple model, let's say linear regression model, and a more complicated one. All of them could be actually part of what we propose, like a drop-in replacements through this process, this pipeline. 2 slides in terms of Caltrack. So Caltrack builds on the time of week and temperature model. So it's a simple regression model that has coefficients for the different hours of the week. And then it splits its modeling approach per month. So you have one model for each one of the 12 months in a year. And they actually go one step further and say that when you fit one model to one specific month, you also use the data from the previous and the subsequent calendar months, but you discount them with a weight of 0.5 when fitting the model. So if you think about it, I mean, what's the rationale behind doing like that? The idea is like defining a neighborhood around your data, and you say that anything that belongs to the same month are very close to my data, so I want to use it as is. Everything that is 1 month before or after, they are away from my data, but not so far so that to discount them at all. So let's use them with a 0.5 coefficient, and anything that it is outside this range, it's completely discarded. So it's like using a kernel function that has this specific variation that is 1, 0.5, and nothing. And usually when you do this because you assume that what you capture in the months before and after will tell you something about the month that you try to model. So it's a way a bit to gain, to borrow predictive capability from these data sets to your specific month. It is a way, it's not an optimal way, because if you think about it, there is no reason to say that months before and after actually have predictive capability that you want to use. And if you go outside this range, there's no information at all. And one of the things that we do is actually try to improve on this design. And if one starts measuring all the parameters, they have 7 or fewer temperature feature because they have a very flexible way to capture U-shaped dependencies between outdoor temperature and consumption. Then you have all these dummy variables indicating the time of week, 7 days of the week times 24 hours. It's 168, this feature. And also there is a binary variable that you can think of it as multiply everything above, that corresponds to whether the specific hour of the week is an hour that during which the building is occupied or not. And there is a heuristic that defines that. It's not a heuristic that works always. In many cases, it is meaningful. So this is the Caltrack approach, and you will see how we actually try to improve this. And one way to improve this is actually through a pre-processing stage that does at least these 4 things. The first is to evaluate the adequacy of the available data you have. It's pretty obvious. You have to check if you have enough data to do any type of predictive modeling. Then we identify common and uncommon patterns in daily energy consumption, what we call data typing. Why we do this? We do this first because we don't want to allow the baseline model to see and learn patterns, the persistence of which we are not sure can be guaranteed in the future. So if you see a pattern that it is recurring a lot of times, it's a frequent pattern, you can assume it actually will stay frequent. But if it's very infrequent, should the model see it and learn it or not? Then we want to define the locality boundaries, the neighborhood around our dataset. And linking back to the Caltrack case, implicitly Caltrack assumes that everything that it is for specific, if we're talking about hourly predictions, okay, everything that it is the same hour of the week in the same month, it's very close to me, I can use it. If it is in the month before and after, it's close enough to borrow something, but let's discount it with 0.5. Anything else should be discarded at all. We try to find better ways to actually define this neighborhood around the observations so that we borrow predictive strength from one subset of the dataset and use it for another. In other words, what you can learn from one subset of your dataset that's actually useful and meaningful when you model around a different subset of the dataset. And then, of course, develop the predictive features that are actually used by the baseline model. So we mentioned day typing. So I have a few slides that explain day typing. The process, right now it's more important to actually convey why day typing is important. The actual process is outlined in our derivable that I will explain at the end of the presentation. But very briefly, let's go through an example. This is an example dataset. In Sensei, we have data from buildings, but these are buildings of the partners, but we also try to use a lot of open source. open data, so that anyone can replicate what we do. One such data set is the data set of electricity, building electricity consumption that Schneider Electric has made available, and the building with site ID 50 is actually depicted here as consumption and temperature. And what we do in terms, what we use as a way to identify these different patterns, we use something that's called distance and matrix profile data structures. There is a dedicated website to that. It's a pretty straightforward process. It's a very efficient thing to calculate. There are a lot of open source libraries that can calculate both distance and matrix profile data structures very fast. Also, it's a process that's very easy to parallelize, so you can actually use more than one core and then apply it on very big time series, larger, much larger than one would expect to see in this kind of applications. A distance profile, very simply, between a time series and a specific subsequence of length m, is another time series that first takes all the potential subsequences of length m of the time series, and then takes the normalized Euclidean distance between this subsequence and the query subsequence. So it's an array with values. All of them are positive, 0 larger than 0, and they tell you how similar each subsequence of your time series is to the specific subsequence or query subsequence. So you can easily spot subsequences that are very similar, because similarity means small distance. Close to 0 distance means that are very much similar. A large distance means they are very dissimilar. And an extension of that is the matrix profile. The matrix profile is actually a process where you can think of it as a way, although it's not calculated like that, you can think of it as taking all the possible subsequences of length m from a time series, and then treat each of them as a separate object. So you have all the subsequence, and then you calculate the distance between each subsequence and all the others. This would mean actually a distance matrix. And the matrix profile is just the lowest value of each row of this matrix. And by definition, you can understand that if a subsequence has a matrix profile value that's far greater than 0, means that the other subsequence in the same time series that looks more similar to it is also very dissimilar. So my closest neighbor in terms of similarity is very dissimilar. What does this mean? It means that as a subsequence, I'm very strange. I'm something that it's not found many times in the data set. Whereas if the value is close to 0, means that the closest in terms of similarity to me, if I am a subsequence, is a subsequence that looks very similar to me. So this is a pattern. This is something that is repeatedly found again and again in the time series. And why we do this? We are searching for 3 things. We are searching for discords, and discord is a daily profile that is maximally different from all the other daily profiles in the dataset. So we're trying to see things that we're pretty much sure that a model cannot pick up, cannot learn to distinguish, or if it actually learns to distinguish, it shouldn't. Why we have discords? Maybe it's because we have outliers. Maybe it's because we don't have enough data. For instance, if we have just 1 year of data and we have a national holiday, it's probably just once. If it has a very specific daily profile, it's only 1 daily profile. We don't have other such national holidays in our dataset because we have just 1 year. So this is marked as a discord. Then we have infrequently recurring profiles. This means that we have profiles that appear more than once, so they are a pattern, but an infrequent one. They are found only a small number of times. Because they are recurring, a model can actually learn them, can pick them up. But it's not always desirable to allow the model to actually learn them. And then you have the frequent recurring profiles. Of course, it's something that the model should exploit in terms of its predictions. And I will explain later how we do it. Just a very brief example. How do you find these chords? Well, you find the matrix profile of your dataset. You take only the subsequences that start at 00 hours, so that you're always talking about a subsequence that spans a full day's period. The length should correspond to 1 day. If I have hourly data, it means it's 24. If I have 50-minute data, it's 96. And then you have these distances. You can plot them, you can do whatever you want. It's easy to use some outlier detection method to find distances that are very large in terms of the other. You can use 3 or 4 interquartile range as a criterion. In this case, I think it's 4. And all the yellow points are days that look very different from the rest of the days. And you can actually sum them up together. And this is actually the daily profiles that correspond to that yellow spots. And you can see that one case is actually an outlier, very large consumption. In other case, you have this baseline consumption, and this makes sense because if it's baseline, there's no profile. There's nothing to be identified. It's more like a random walk around an average level. And I can tell you that this corresponds to actually holidays. But because they don't have a structure, they don't have a profile, they cannot be matched, so they are marked as discords. And these are all the other daily profiles that are not marked as discords. And even visually, one can spot at least 3 patterns. Okay, can spot cases where the high load period is from 8 o'clock to in the morning to 8 o'clock in the evening. Some cases where it's actually consumption starts to drop at 1 p.m. It is also this spike at the early morning hours that is repeated but strange, seems pathological. And the question is how can actually allocate all the consumption profiles so that we identify different clusters, we identify patterns that we can actually spot visually. Very briefly, we don't do it through whole days. We actually prefer to split the profiles into 3 not overlapping 8-hour intervals. This makes things more robust. It's easier to spot differences where you have a smaller span to care about. The process is a repeated process that first finds. So the main idea is that we want to identify a very small number of recurring profiles that are very different from one another, and then just classify or allocate all the remaining profiles according to how similar they are to these profiles. We do this in an iterative process where we find the minimum value of the matrix profile, because that means it's a repeated pattern. And then in each case, we update this matrix profile by dividing it with the distance profile of each time selected reference pattern. Why? Because when we divide the matrix profile, we're trying to find cases where we have very low numbers. When the matrix profile is very low, means it's a repeated pattern. Where the distance profile between our time series and the selected reference pattern is very large, means that it's a recurrent pattern, but it's very unlike to the reference pattern that we have already found. So we divide a small number with a large number. This makes it smaller. So we always care about the smaller values in this iterative process of updating the matrix profile. It's explained in a little bit more or a lot more detail in the deliverable. I don't want to go into too much detail right now. The idea is that there is a process. This process actually can stop based on some criteria. We have one, but we can actually use a lot of different ideas. You can start with a predefined number of the maximum number of these different profiles you want to find. The actual result is that we have, in this case, 4 profiles that are repeated. So you can find similar to these profiles subsequence, daily subsequences in our dataset. They're very different from one another. So it makes sense to actually use them as a way to distinguish the different profiles. And if we do this process, if we allocate all the subsequences according to how similar they look to each one of these 4, we get something like that. And okay, one can see 2 things, for instance. One is that in some cases we have a lot of data, so we have a lot of profiles. So we have these frequently recurring patterns, in some cases, just a few. The other important thing to think about is that anytime we have a cluster of these profiles, we actually have a neighborhood. We can say that the data there are closer to each other than the data in the other clusters. So implicitly, we have found a neighborhood that we can use to borrow statistical strength and develop and train predictive models without relying to this initial idea of Caltrack when we say that you only borrow from the month before and the month after, and that's it. Just another example, if we do the same for the interval from 4 p.m. to midnight, we can get these 2 different profiles. And if we use these 2 different profiles to actually split our data, you will have these 2 clusters. And you can do it also for the middle part, etc. Why this is important? Why we do it? Why we use the data typing information? First of all, instead of using the Caltrack approach, where you fit one model per month, you can fit one model per cluster. And it actually makes more sense because you don't have now hours per week, you just have hours of day. And because all these profiles are close to each other, you have a natural way to allow sharing predictive strength to be shared among the same hours in a cluster. So for same hour, different days, there is something that I can learn for all of them and include it in the model. So this makes my model more accurate. And also because I now think in terms of hours of day, not hours of the week, I actually have a smaller number of parameters to calculate, to estimate. And the other thing is that this distinction between frequent and infrequently and infrequent patterns means that I can now decide what my baseline models should see. These infrequent profiles, is it something that should be used or not when we create the predictive model? And the answer is you don't know, but you can always think in terms of minimizing regret. This idea that it's a decision under uncertainty. So min-max regret. Try to minimize your regret by comparing the effect of hiding this data, these patterns, when the model should actually see them because they're actually persistent. And compare this to a case where you allow your model to see it, but you shouldn't because they are pathological, they just one time, they won't be repeated. The idea of regret goes hand by hand with the fact that when we do predictive modeling, we don't care about the general predictive accuracy. This would make sense if all savings are equally valuable during all hours of the year. But we don't do this in Sensei because the whole idea is that the value of an energy efficiency project depends on the time periods during which these consumption changes occur. And this, of course, depends on the characteristics of the grid. For instance, we are focusing on hours where you have high probability of load loss, because this is when you need capacity. So if you want to mitigate the need for extra capacity with energy efficiency, this is what you should target. And cases where you want to mitigate the need for rubbing reserves when you have known a persistence variability in the net load, okay, when you have dips and peaks in terms of your net load. Because we care about specific hours during the year, we care more about the predictive accuracy in these periods. So if it doesn't affect so much these periods, the regret is different than if it actually affected it. Summing up, sources of additional information. We have a deliverable that's called 7.1, methods for the dynamic measurement and verification of energy savings. It's expected to be published in the project's website this month. It describes in detail all the pre and post-processing steps in terms of workflows, the rationale, the theory, and the implementation. It will be accompanied by an open source software library that actually implements these workflows, because the idea is not only to say we have this interesting idea, but allow people to play with it, to use it, to actually see it in practice, and even hopefully improve it. And even when the deliverable gets published, we will have new material in terms of measurement and verification, because it's an ongoing process. So I would ask you to join our stakeholder community to stay informed, but also the stakeholder community is a way of us to get feedback on a lot of ideas through consultation process, and collect reactions to things that we propose. And this is the end of my presentation. You can see the link for the stakeholder community if you want to join. Any questions or comments are welcome.
All right. Thanks, Sotiris. I will confirm that everything's okay once this is done processing.
Okay.
All right.
Perfect.
Thanks again. Sorry for the inconvenience, and hopefully we should be all set.
It's okay. No problem.
All right. Take care, buddy.
Okay. Bye.
Bye-bye.